So in our last class, we worked this example where we were trying to see if the proportion of adults in Nebraska that are considered obese is significantly less than this 35.7% that was given. So we went through all of that. We found the p-value, the test statistic, and all these things that we did by hand. So what I'd like to do in this video is show you how we can actually use StatCrunch to, one, help verify this, but that way also once you leave my class, you're not necessarily having to do the whole thing by hand, but you know what's going on behind the scenes and then just can use StatCrunch to get to your answer more quickly. But in class, you will be doing this by hand. Again, just going to try to show you so you're going to be able to double check to see if your numbers are right. So the first thing that we're going to need to do is actually just bring up StatCrunch. And again, whether you have the My Stat Lab or you just got the access to StatCrunch itself, you just want to log in here. Now for these questions, I didn't have an actual data set, but I will actually pull up a data set so you can kind of see how that works here in a moment as well. But so right now, I'm just going to use Open StatCrunch. And if I look at the directions here in my notes, which I've already given you the output we're going to use, we're going to talk about how to do it. So we're going to go to Stat, Proportions, One Sample with Summary. So we're in here. We're going to go to Stat, Proportions, One Sample with Summary. And what pulls up here is I need this thing called the number of successes and the number of observations. Where I'm going to get that from is actually the very beginning part of my problem here. And actually from my graph. So the two numbers I need are actually these two numbers that we use to create p hat. So if I look at that, you can see that I want 304 is going to represent my number of successes, and the 900, which would just be my total sample size, is my number of observations. So it's just this 304 and 900 that we're going to use. So there's 304, basically the number that were obese, over the total number of people sampled. Then the next thing it says that I need to do is enter the number in the null hypothesis and then adjust the sign for the alternative. So if I go back where we had actually written our hypotheses for the first time, I want my hypotheses to look like this. So I don't want to have that 0.5 that's showing up in StatCrunch. I want to have this 0.357. So I'm just going to change that to be 0.357. If you notice, the number below automatically changes because that number is the same every single time. And then for my sign of the alternative, I want this less than sign. It always defaults to this not equal to, but if you use the click down menu, you can change it to any of the three signs that we've talked about. And then I'm just going to choose the less than. I can confirm that these look like the hypotheses I have here before I go any further. Then we're just going to hit compute. So here is the output that we get, and we're going to compare these numbers to what we actually got by hand. So when we did the hypothesis test, if this will let me scroll, we got some different values. We got a p-value, we have this test statistic up here, actually some different numbers. So let's go through what each of the numbers that StatCrunch is actually giving me. So the first thing it outputs to you are actually the two numbers you gave it, so the 304 out of the 900. It then actually gives you the sample proportion, which is this 0.3378 that we calculated way up here in the beginning. Right, so our p hat was 0.3378. Then it gives you this standard error. So what that standard error actually is when we calculated our test statistic, or our z, that's that bottom number. So when we did it, we got 0.0160. They got 0.01597, so that's going to round to the same number that we have there. And then it gives you your z-stat, which is actually your test statistics. They got negative 1.203. We got negative 1.20, so notice that that's very close as well. And then the last number they give you is their p-value. Now the one thing to notice about the p-value is you're probably not always going to get an exact match, because we were doing things by hand. We had to round some numbers, like right for our z's specifically, we have to use only 2 decimal places. since it's a computer, it can use all of these decimal places that it has to calculate your p-value. So the p-value might not be a perfect match, but it still should be relatively close. So our p-value we got was 0.1144 in StatCrunch. From our table we got 0.1151, and so you'll notice that is pretty close to what we expected. Now, if you'll notice here, that was with our example with 900. We're going to do the same thing with our example of 1800. So that was our part H that we did. So all I'm going to have to do is change my new numbers. Is my number of observations is this 1800, and my number of successes is 608. So I'm going to go through StatCrunch and redo the same thing. So we're going to go to that stat, proportions, one sample with summary. This time we had 608 successes out of the 1800 people. Our hypotheses stayed the same, but it didn't keep it there for me. I've got to adjust those to match again. And then hit compute. And now if I compare these numbers, so sample proportion stayed the same. Standard error is 0.0113 from the output. And that's exactly what we got for that square root part on the bottom. So that's what that actually is. For RZ, we got negative 1.7. They got negative 1.7. But again, their table is much more expanded than ours. We could have a slightly different p-value. So I got 0.0444 using StatCrunch, and we got 0.0446 when we did it by hand. Now, something to note when you're going to StatCrunch is do notice, if I go back here and edit it, the alternative hypothesis sign does make a difference. If you remember, for us, that's going to tell you which way you're going to shade. If we have a less than sign, it means we're shading left. So for instance, we got to go straight to our table and get our p-value. If we're shaded right, it's going to be the 1 minus rule from the number we get from the table. Then we have that not equal to. What we learned is actually one of the p-values is just double. So what you'll notice is how the p-value is going to change as I change the sign. If I change this sign to a greater than, it's now going to be using the 1 minus rule. So my answer here is going to be 1 minus this number I see here. So if I do that math in my head, I'm going to get 0.9556 if I'm going to shade right instead. So let's check to see if that was right. Alright, and there's that. Just again, it's just shading the opposite direction. Now going back to where we were before with that less than. So again, there our p-value is 0.0444. And so if I change that to a not equal to, let's first remember what that means our picture is going to look like. So if instead here our HA was P was not equal to 0.357, when I get to step 4, what my picture would look like, remember there are pictures always based upon Z, I would take my test statistic that I calculated, that negative 1.70. Then I look at my alternative hypothesis to figure out which way I shade. Since this one's a not equal to, we're going to have everything to the left of negative 1.7. And then everything to the right of positive 1.7. And what we found is that this area and this area are the same size. So what I think should happen to my p-value is going to be 2 times what I got up here when I did just the less than piece, or when I did just this piece. So if I were to do that, I'm going to expect StatCrunch is going to give me a p-value close to 0.0888. So let's see what we get. Again, pretty darn close than rounding because they were able to use a more exact table here. But so notice that if you put in the wrong alternative hypothesis sign, you are going to get an incorrect p-value. So please keep that part in mind. Alright, also hopefully by seeing this video, when you're going to want to use StatCrunch possibly on your extended assignments or want to check things at home, you can kind of see again how to go through all of the different clicks to get your answer. So the next video we will do another example of doing a hypothesis test, and we'll also show how we get that in StatCrunch as well.